Hey guys, it's Mrs. Meisman, and today we're talking about Chapter 2, which is talking about motion or the change of position. Mainly we're talking about speed, velocity, and acceleration. To start with, we're going to talk about rate. Rate is a quantity divided by time. It measures how fast something changes. Examples of rate include speed, acceleration, velocity, and power. Measurements. All measurements are either vector or scalar. Starting with vector, a vector quantity is a measurement that has both magnitude and direction. Vector quantity can be represented with an arrow, with the length of the arrow and the orientation of the arrow. As you see, the arrow, the length of the arrow, is the magnitude, 100 meters per second. Its head is its direction. It is pointing east. Vector quantity has both magnitude and direction, whereas scalar quantity only has magnitude. An example of a scalar quantity is speed, 100 meters per second. It does not involve direction. Think of other things that we make measurements of that do not involve direction. You might think of time, and mass, and length, or distance. These are all scalar quantities because they do not involve direction. If you want to know if something changes its position or not, you need to compare it to something that is stationary. This is tricky, because even when we're driving down the interstate and there's a car that's beside us in the passing lane and we're both going the same speed, we can tell we're moving because of the ground and trees and other things around us. But what if it was just the two cars traveling down the interstate side by side and you couldn't see anything else? Would you know if you were moving or not? No, you wouldn't. So when you're trying to decide if something has changed its position or not, you need to compare it to something that is stationary or at rest. Distance. Distance is how much ground an object has covered during its motion. It does not consider direction. Direction has nothing to do with distance. It is a scalar quantity. An example, if I wanted to know how far I traveled, and this was my path, I would add 4 meters to 2 meters to 4 meters to 2 meters. That would be how far I traveled, which would be 12 meters. That would be my distance. Displacement is different than distance. They're related, but they're different. Displacement is an object's overall change in position. If you're into math, here's an equation. To find the change in position, you could take the final distance minus the initial distance. I'm not into equations. Displacement depends on direction. Therefore, it's a vector quantity. So let's look at the same example that we just looked at for distance. So I like to look at displacement as I'm comparing it to where I was in the beginning to the end. Am I at a different location? The distance from A to the end, B, that is my displacement. So let's look. If I start at the very beginning, where do I end? I end at the very beginning. So was I displaced? No. There is no displacement whatsoever. There was no change in my position. Let's look at this example. The red line shows the distance, or how far I traveled. It is farther than my displacement. Displacement is the difference from the beginning to the end. The displacement is represented by the green line. Speed. Speed is a measure of how fast something is moving. Air is the rate at which distance is being covered. It is a scalar quantity. An example, 300 miles per hour. The equation to solve for average speed is distance divided by time. Constant speed is covering equal distances per equal time intervals. This is clearly shown in the illustration. As you see, as 1 second passes, I am, for each second, covering a distance of 10 meters. Therefore, my speed remains the same. Instantaneous speed is the given speed at any instant in time. It's the speed right then, at that second. Check out the egg as it breaks. Instantaneous speed in your real life is the speed trap. Or it's looking at your speedometer when you see the cop's lights flashing behind you. This is instantaneous speed. Doesn't help to slam on your brakes. He's already clocked you. Average speed is the total distance covered divided by the total time interval, or the total time that has passed. So your total time is 3 minutes. Your total distance would be 180 plus 140 plus 100. Adding that all together would give you your total distance. Velocity. Velocity is speed in a given direction. So yes, it's very similar to speed, but it also considers direction. Rate at which an object changes its position. An example of velocity is 761.207 miles per hour, but it's a vector quantity, so don't forget the direction, east. This is a jet breaking the sound barrier. Above is the speed that the jet would have to be traveling in order to break the sound barrier. To solve for velocity, it is displacement divided by time. Again, going back to that vector quantity. Constant velocity is only possible when the velocity is linear, because speed and direction have to be constant, because velocity is a vector quantity. Changing velocity, a change in speed or direction. So you can change your velocity by changing your speed and or your direction. Average velocity is the total displacement divided by the total time. Yeah, it sounds like average speed. The key word, though, is displacement, not distance. Acceleration is a change in velocity divided by the time interval. So if you look at the first diagram, you can see that the car is speeding up. You know that the car is speeding up because the distance between the little circles increases. The second diagram shows the car is slowing down. You know the car is slowing down because the distance in between the little bubbles decreases. Acceleration is a change in velocity. Velocity can change by speeding up, slowing down, or changing directions. So in the last diagram, what I've tried to draw is an object traveling at a constant speed, but it's accelerating because it's changing direction. Yes, something can be accelerating by changing direction only. Now there's positive acceleration. Positive acceleration is when acceleration and velocity are in the same direction. When this occurs, the object will be speeding up. Negative acceleration is when acceleration and velocity are in opposite directions. In this case, the object is slowing down. Thank you. Hope this helped. Let me know.